Okay, so let's talk about someone who is literally reshaping our world right now. I'm talking about NVIDIA's CEO, Jensen Huang. His company started with video games, but now it's at the very heart of this massive technological earthquake we're all feeling. And when you hear his vision for the future, wow, it's just breathtakingly ambitious. He says, and I quote, "Everything that moves will be robotic someday, and it will be soon." I mean, you gotta understand, that's not just some casual prediction. For him, that's a mission statement. So you have to ask yourself, right? How did we even get here? How does a company that was all about making graphics chips for gamers suddenly find itself powering, a new industrial revolution? It's an incredible story, and that's exactly what we're gonna unpack. All right, so to understand this, we have to go back to the beginning. It all starts with this one single, really foundational idea, a completely new way of thinking about what a computer even is. So, way back in the 90s, NVIDIA had this key realization. They saw that basically every computer program has two very different kinds of jobs to do. You've got the sequential part, that's what a CPU is for, solving one complex problem at a time, step by step. But then you have the parallel part. We're talking thousands of smaller, simpler tasks that can all be done at the exact same time. Think of it like this: one super precise paintball sniper versus a huge wall of paintball guns all firing at once. NVIDIA's big bet, their whole thing, was that the perfect computer had to be amazing at both. And they didn't just stop there. They built on that bet piece by piece. So they get founded in 93, they invent the very first GPU in 99, and then boom, the masterstroke in 2006, CUDA. Now, CUDA was the game changer. It was this platform that let developers use all that massive parallel power for any kind of problem, not just making video games look pretty. It's like they built this incredible stage, and they didn't even know the AI superstars were about to show up. And the impact was just profound. And this was way before the whole AI thing exploded. Jensen Huang loves to tell this story about a quantum chemistry scientist who came up to him and said, "Jensen, because of what you've built, I can do my life's work in my lifetime." Just think about that. NVIDIA hadn't just made a faster chip, they had literally built a time machine for science. Okay, so the stage was set, right? The technology was there, waiting. All it needed was that one little spark to ignite what we now call the AI Big Bang. And that spark came in 2012. This was the famous AlexNet moment. Some researchers used NVIDIA GPUs to train a neural network, and it just completely shattered all the records for image recognition. Now, for most people, it was like, that's an interesting result. But for NVIDIA, it was a giant flashing signal. They immediately pivoted the whole company. They basically asked, okay, what does this really mean for the future of computing? And then they bet everything they had on that answer. And this whole thing led Jensen to come up with this really powerful new concept he calls Software 2.0. See, for decades, making software meant a human programmer had to write out every single instruction, line by line. But in this new era, the computer learns from data to write its own software. We call that software a model. It's not exaggeration to say the fundamental way we create software was totally reinvented. But, there's a real philosophical depth to this. It's not just about code. Ilya Sutskever, one of the co-founders of OpenAI, explained it perfectly. When you train a huge network to just predict the next word in a sentence, it's not just learning statistics. To be good at that job, the network has to learn a compressed, abstract, sort of understanding of the world itself. It's learning about people, about their hopes, about the human condition. It's actually learning a model of reality. So this new kind of software, this ability to learn a model of reality, this isn't just some small technical shift. According to Jensen, this is the engine of a whole new industrial revolution. And he has this really powerful analogy for it. He says, look, past revolutions built infrastructure for electricity, power plants and grids. Then we built infrastructure for information, the internet. Well, this AI revolution is building the next fundamental layer, an infrastructure for intelligence. And these things we're building, they're not just data centers anymore. There's something totally new. He actually calls them AI factories. Think about it. A normal data center, it just stores and serves up information. An AI factory, on the other hand, manufactures intelligence. It takes in raw data and energy as its input, and what it produces is a valuable new commodity, tokens. Those tokens are the building blocks for every AI response. And that means these factories are actually revenue-generating facilities. And the scale of this, it's almost impossible to wrap your head around. You've heard of Moore's Law, right? Doubling computing power roughly every 2 years? Forget about it. In just the last 10 years, NVIDIA's AI platform has delivered a 1 million times increase in performance. Let that sink in. 1,000,000x. That is the insane, hyper-accelerated engine that's driving this whole revolution. Okay, so we're manufacturing intelligence at this unbelievable scale. The obvious next question is, so what? What's the next step? How does all this digital brain power actually start to interact with and even reshape our physical world? Well, the bridge between the digital and the physical is built with this really fascinating stack of technologies. Let's break it down. Step 1, you create a digital twin. That's a perfect, physically accurate virtual copy of something in the real world. A car, a whole factory, whatever. Step 2, that twin lives inside what they call the Omniverse, which is basically a simulated world that acts like its operating system. And then, the really wild part, an AI called Cosmos generates infinite new situations inside that world, creating the ultimate training ground for robots. And it's all based on the real laws of physics. And this is where we meet Grek. It's a robot that Jensen Huang showed off at a recent keynote. And get this, Grek learned how to walk, how to jump, even how to dance entirely inside that simulated Omniverse world. So when it finally took its first step in the real world, to the robot, it was just another variation, just another data point among the thousands it had already experienced. The physical world was just one more simulation. So when you see these incredible tools for building and training intelligence, you have to ask the biggest questions, right? Where is all of this heading? And maybe more importantly, what does it mean for us? And the ultimate question, the one on everyone's mind, is about AGI, artificial general intelligence. Are we getting close? Are we about to create an AI that can match or even beat human intelligence across the board? Well, when Jensen Huang was asked this exact question, his prediction was startlingly bold. He said that if you define AGI simply as an AI that can pass a whole battery of human intelligence tests, well, in that case, he said we'll achieve it within the next 5 years. Coming from the guy who is literally building the engines that are making all this possible, that is a timeline you really have to take seriously. Okay, but if AGI really is coming, what does that mean for our jobs, for our skills? Here's where Jensen's view gets really interesting. It's surprisingly optimistic, and it's all about democratizing technology. He said, and this is a powerful quote, "The technology divide has been completely closed. Everybody in the world is now a programmer." Think about that. The miracle of AI is that you can now tell a computer what to do just by talking to it in plain English. This just completely flips the script on what skills matter. If the AI can handle the how, all the complex coding and the technical stuff, then our job as humans is to provide the what and the why, your unique knowledge, your specific experience in your field, what Jensen calls your domain expertise. That becomes the most critical ingredient. That's the new currency. It's how you guide these incredibly powerful tools to do something useful, something creative, something brilliant. So, this is the new reality we're all stepping into. And it leaves us with this one really profound question to think about. In a world where intelligence itself can be manufactured, what then becomes our most valuable human skill?